Today we are going to learn in C programming how we will automate the compilation process if you have multiple header files and C files. To do that, first we are supposed to write a C programming. So here is a sample example. So here what I have considered here is I have written a one program called hello.c. So in this program I am calling a header file which is externally been defined. So here this function _1 is present in a header file called hello underscore function.h, where it has been declared and it is defined in hello underscore function.c. So what is the difference between definition and declaration? In declaration we are only specifying the name and characteristics, but it doesn't allocate any memory, whereas in the definition of one particular function we are going to expand the body of the function. Now if I consider the expansion, that is a definition of this function which is written in hello underscore function.c. So here you can see that I am expanding, that is I am defining this function _1 where it is printing some statement like hello makefile. So here again I am including, or I am trying to include a header file, because this function definition I have written in this hello underscore function.c, but I am not declared here in this file. So where I have declared, I have made a one more header file. This is an header file where I have declared this function, which is a void function _1 open and close bracket semicolon. Now if I want to run this code, I have to add what is the compiler I am using, what will be the output file, that is a hello, and what all the other files which is dependent for hello.c. Why hello.c is dependent on hello underscore function.c means it is having it is having the function called function _1. So for that reason I am including this. This is sufficient for if you have one or two files which is dependent on one particular programming file. But if it is n number of files, that is it may be some 20-30 files or header files which needs to be included in the present working coding file, then this compilation step is not sufficient, because it will include you are supposed to include lot many header files in a single command line. So that is a challenge. So just I am going to see what is the output of this. So if I give the ls, you will get an executable file. I will just execute this hello. So you got an output hello make file. This is an output, simple, because there is only one dependency file. If you have multiple dependency file, using in the command prompt becomes challenge. So to do that, we are introducing, or I am explaining about a Makefile script in this session. So to do that, one more important thing you should understand is here I am using -i. What is an -i means? This is a dot which presents which says that it specifies that the header files are present inside the current working directory. That means dot specifies that all the header files are in present working directory. Okay. Next, Now I have to automate this command. To automate this command, automate the compilation process, here I am considering the Makefile. It is a script which compile and build a process for the program. To run this Makefile, okay, if I consider this, to run this Makefile, I have to use a command called make. Make is a command which runs the Makefile. So how the Makefile has been written? First we will see that. I'll just go with nano Makefile. So here it's a script. What each line of the script says, we'll see one by one. CC is a cross compiler that is used to compilation. Here since it is a C program, I am using GCC. If it is a C++ program, we will be using G++. Next, the C flags. The C flags represents that all the header files are present in the current working directory. That this dot represents current working directory. Next, dependencies. So this dependencies, what is the dependency for your main hello.c program? The dependency is hello_function.h. This is an header file. Next comes %.o. This is a generic pattern for compiling. This line says that all the .c files has to be converted into .o files. Okay, all the .c files has to be converted into .o files. See here, .c files are converted into .o files, where CC is a GCC here I am using, and then here this command represents the target file. The target file is a .o file, and then next this represents the first prerequisite, that is a .c file. Next here this represents, it includes any additional compiler files, that is -i. So I will be repeating again. Here GCC represents compilation is CC represents compilation is GCC. Next -c to -o, that is all .c files are converted into .o files. Next this represents the target file. The target file is a .o file, and then this command represents the first prerequisite. The first prerequisite is .c file, followed by flags. Here the flags is -i. Next line, this next line, it will link the hello.o file, okay, this hello.o file and hello function.o file into an executable file called hello_1. Okay, I'll repeat again. Here this line states that hello_1 file is an executable file, and hello.o and hello_function.o both are linked, and then it generates an executable file called hello_1. So how to execute this? Just type make. So you can see that what all the commands have been executed. First one -c -o. So here hello.c is converted into hello.o. Next cross compilation, hello_function.c is converted into hello_function.o, and then these two .o files are linked to an executable file called hello_1. So if I see that there it creates an hello_1. If I execute this, you got the output. Okay, thank you.